All right, let's talk about a skill that's absolutely fundamental in Python, something that takes a simple script and turns it into a real application. We're talking about file handling. Basically, we're going to give our programs a long-term memory so they can actually remember things after we close them. Let's get into it.
I mean, think about it, right? You write a program, you run it, it does some awesome calculations, maybe it gets a user's high score, and then you close the window. The second you do that, poof, everything is gone. It's like it never happened. Every time you run it, you're starting from scratch. That's digital amnesia, and it's a huge problem we're about to solve.
To really get the solution, you have to understand the two kinds of memory your computer deals with. First, you've got your program's memory. That's where your variables live. It's super fast, but it's temporary. The moment the program stops, it's wiped clean. But then you have disk memory, your hard drive, where files live. It's a bit slower, but it is permanent. And that permanence, well, that's the key to everything.
So yeah, let's really frame the problem we're dealing with here. These programs that just forget. They're fine for a quick one-off calculation, but they can't remember user settings or save their progress. They just lack persistence.
And here is our solution. It's files. By learning how to read from and write to files, we're basically building a bridge from our program's temporary forgetful memory to the computer's permanent storage. This is what gives our programs the power to save their state and become way, way more useful.
Okay, so how do we actually do this? The very first step is opening a file. A good way to think about it is to imagine your computer's hard drive as a giant filing cabinet. Before you can read or write anything, you've got to find the right folder and pull it out.
In Python, the command for this is the open function, and it needs two key things from you. First, the file name. That's like the label on the outside of the folder. And second, the mode, which is you telling Python your intentions. You know, hey, I'm just planning to read from this folder, or I'm about to write some new stuff inside.
And these three modes right here are the ones you're going to use constantly. R is for read, simple enough. A is for append, which is great because it lets you add new information to the very end of a file without messing with what's already there. But you've got to be really careful with W for write. Look at that catch. If you open an existing file in W mode, it will completely erase everything inside before you even start. It's powerful, for sure, but you have to be careful.
All right, so we've pulled out our folder, we've opened it in read mode. Now what? How do we actually see what's inside? Well, Python gives us a few different tools for the job depending on how we want to get that information.
First up, we have read. This one is the most straightforward. It's like taking all the papers out of the folder and getting them as one giant document. It reads the whole file, from the first character to the very last, and gives it all back to you as one single string.
But what if you have a massive file? You probably don't want to load all of it into memory at once. For that, we have .readline. This method is much more precise. It reads just one single line and then stops. But it remembers where it is, kind of like a bookmark. Call it again, you get the next line. It's perfect for processing files piece by piece.
And finally, there's .readlines. This one reads the entire file, but instead of giving you one giant string, it splits the content up at every line break and gives you back a Python list. Each item in that list is a string representing one line from the file. This is incredibly handy when you want to loop through each line individually.
Okay, we've got reading down. Let's flip the script. How do we get information from our program back into a file? This is how we save our data, how we save our progress, and luckily, it's just as straightforward.
Here are the key rules. You use .write to put a single string of text into the file. If you have a whole list of strings, .writelines is the tool for that. But, and this is a big but, pay close attention to that last point. Python does not automatically hit enter for you. If you want things to be on separate lines in your file, you have to manually add that new line character, the /n, yourself. It's a classic rookie mistake to forget that.
Now, we've covered opening, reading, and writing, but let's get to the single most important best practice in all of file handling. This is the modern, the safe, the professional way to do all of this.
Just look at this comparison. The old way, the manual way, you had to open a file, do your work, and then you had to remember to call f.close. If your program crashed before that line, or if you just plain forgot, you could lose data or corrupt the file. The automatic way, using the with statement, handles all of that closing stuff for you. It's the best practice for a very, very good reason.
And this right here is the whole point. It's a guarantee. It doesn't matter what happens inside that block of code. Your program could hit a weird error and crash,
Python still guarantees that the file will be properly and safely closed. It's all about protecting your data.
So if we go back to our filing cabinet analogy, using the with statement is like hiring a perfect assistant. You pull the folder out, do whatever you need to do, and the moment you're done, that assistant flawlessly puts it back where it belongs. Every single time. No exceptions.
So theory's great, but let's put it all together. Let's see how this stuff works in a real-world scenario. How would we build a super simple to-do list application that actually remembers our tasks from one day to the next?
Well, here's how the logic would work. When the app starts, you'd use with to open your tasks file and R mode to read and display any tasks you already have. Then, when a user wants to add a new item, you'd use with again, but open the file in A mode, append, so you can add the new task to the end without erasing the old ones. It's a perfect example of using different modes and wrapping everything in the safety of that with statement.
So if you take only one thing away from this whole explainer, let it be this. The with statement isn't just some optional fancy shortcut. It is the professional standard for working with files in Python. It makes your code safer, it makes it more reliable, and frankly, it just makes it easier to read.
And that brings us to a final thought. You now have the power to give your programs a permanent memory. You can read, you can write, you can save data reliably. So what's next? Imagine a giant log file from a web server with thousands of lines being added every minute. How could you use these skills to write a tool that automatically scans that file and pulls out only the specific error messages you're looking for? The possibilities are now wide open.